Open the Frontend project to configure the virtual environment and open config py. Import OS. From .env, import load.env. Make sure that the .env file exists in project root and load the file. Create config class. Set secret key value by generating a random token from the secrets package. Also set the random value for WTF underscore CSRF underscore secret underscore key by the same process. Create the development config class. Within that class, set env to development and debug to true. Create production config and write down the path keyword. Open the .env file and set the required configuration. Let's now edit init.py. So import config, import OS. From Flask, import Flask. Import Bootstrap. Import Login Manager. Create a global project of Login Manager and Bootstrap. Optionally, define upload folder where applications can be used to store the images. It can be used to upload new product images. Start create app to initialize the core application. Within create app, create the Flask app object. Set the Flask app config upload folder attribute. Load the environment-specific settings from .env. Initialize the login manager and set the login message and login view. Initialize the Bootstrap plugin. And start the app context. Here we define the blueprint, and finally we return the app. Open run.py. From application, import create app. Configure run.py as the entry point of the application. Declare Flask app variable in .flaskenv. Within the application/frontend folder, open up the init.py file. From Flask, import blueprint and create a blueprint object. Import views. Within the app context, import the blueprint and register it. Open forms.py to create forms required for websites. From flask_WTF, import Flask form. From WT forms, import string field, password field, submit field, hidden field, and integer field. From WT forms.validators, import data required and email. Declare a class name login form inherited from Flask form. Create a string field object named username. Also use the data required validator. Create a password field object named password with the validator of data required. Create a submit field object named submit. Write down the registration form. Create string field objects of username, first name, last name, and email. Email object has an additional validator named email. Create a password field object with the data required validator. Lastly, create a submit field object. Write a class named OrderItemForm. Create a hidden field object named ProductID with the data required validator. Create an integer field object named quantity with the validator data required. Create a hidden field object named OrderID. And lastly, create a submit field object. Declare a class named ItemForm. Create a hidden field object with the data required validator named ProductID to track products on order. And create another hidden field object named quantity to track item quantity. Import requests and start a class userClient. Within that class, write down a static method post-login and put the form as an argument. Declare a variable API key and set its value to false. Now declare a payload dictionary where the first key value pair is username and form.username.data, and the second key value pair is password and form.password.data. Save the API URL into a variable. Create the post request with the URL and payload. If there is a response, then convert it to JSON format and save in variable D. If there is an API key value available in the dictionary, then save that value in a variable API key and return it. For testing, we need to hard code some values until we create some logic in views.py. So remove the form argument from post login function and replace hard-coded username and password values in there. Open Flask shell. Import user client and run the function userclient.post_login, and it will return the API key in response. Create a getUser method in order to return the logged in user information. Define the headers dictionary with the key authorization and the value of API key saved from the session. Write down the URL in a variable and then pass a GET request to the URL with headers defined above. Save the response and convert it to JSON and return it. Before testing, replace session user API key with the hard-coded value of API key variable. Later we use sessions in HTML templates. Test the API as follows: import application.frontend.api.userClient. Call userClient.getUser to get the user information. After testing rollback, change and replace API key in headers dictionary with session user API key. You can also remove the API key variable above headers. Post user create, take the form as argument. Create a payload and get the values for email, password, first name, last name, and username. Save the required URL in the variable. And then send the post request to the URL, including the payload. Upon successful user creation, convert the response to JSON format. To test the API, just remove form argument from post user create method and pass payload dictionary variable with hard-coded values. So here we put in hard-coded values. Then run the Flask shell and create the user using user client post user create. Then after testing, roll back the changes you made. Create does exist with the username as the argument to check if the username already exists or not. We will use this method at the time of registration of the user. Save the URL in a variable and pass it to requests.request with get method. Return the response if the status code is 200. It denotes the existence of the username. Otherwise, the username is available for registration, which we will see when working with views. To test, open Flask shell and import user, client, and run the user client.doesExist, like so, to check if it exists. Import requests. Declare a class product client. Within the class, write down a static method name getProducts. Use requests to get the product list from the API endpoint. Convert the response to JSON and return. To test the program, open the embedded Python console and start Flask shell. Import the product client and call the getProducts function. The next method in product client is get_product slug, which fetches a single product based upon its slug. Access the endpoint to get a single product based upon its slug. And convert the response to JSON and return. And here we get a single product based upon its slug. From Flask, import session, import requests, and start a new class order client. Within that class, add a static method called getOrder. Make a header which has basic authorization with API key. API key. Create a request for the API endpoint. API order, the endpoint. And then pass the headers. Convert the response to JSON and return the order. Now we need to test order client.getOrder. So replace user API key session value with a hard-coded API key value for testing purposes only. We will use this API key during testing all methods of order client. Import order client and run getOrder. If the user has an open order, then you will get that information. Otherwise, you will get a no order found response. Write another static method, post add to cart, product and quantity, where users add a product to cart. The arguments required in the post add to cart method is product ID and quantity, which is set to 1 by default. So make a payload dictionary with the product ID and quantity, save the URL in a variable, and create a header to be passed to the URL. Then pass the request to the URL with the payload and headers information. Convert the response into a JSON format and return it. To test the method, import the class and run the post add to cart with product information. Make sure to use a test API key value from the database, unless we use sessions in the front end. Now we use the post checkout method, configure URL with header information, and send a post request. Save the response in a variable, convert the response to a JSON format, and return it. Now we'll test the API. At the end, reset the order with session. Finally, we come to a point where we write down views as blueprints and direct the output to HTML templates to see the front-end website in action. Now, here we define what is going to be displayed on the home page. So first we check if a user is authenticated. We display the order of that user from the session. Now we display the products using productClient.getProducts. To avoid any sort of error being displayed on the home page, we try to use except block and handle any exception in case we're not able to connect to product API. In the end, render the HTML template home/index.html page and pass the products to the HTML template. Open index.html in templates home folder. First check if there is any product available, then loop through the products passed from view. Otherwise, display a no product available message on the front-end homepage. Now run the project and verify if products have been displayed on the homepage. Now we write down the logic for the registration page. Add /register blueprint with get and post methods. Here we use the get method to display the registration form and post method to submit the form data. Define a register method, create form object from registration form. If the request is post, then perform the validate on submit that collects and validates form data fields before submitting. In the next step, save the username form.username.data. Now check the existence of username using user client. If the username already exists, then display an error flash message to input another username and return the registration page. Otherwise, send the form to user service via userClient.post_user_create form. If the user created successfully, redirect to the login page. Otherwise, if form.validate on submit returns false, then return an errors found flash message. Use the render template function to render HTML template and pass form data. In register.html, add a form with post method. First class tag would be form.hiddenTag. This template argument generates a hidden field that includes a token that is used to protect the form against CSRF attacks. Next, use a macro render field to render a form field over Ginger templates. First field is username, next is first name, then last name. Final fields are email and password. In Ginger templates, double curly brackets allow us to evaluate an expression. In the end, we submit the form. So we use submit to submit the form with some Bootstrap classes. For login, add a root login with get and post methods. Start the login method. Check if the user is already authenticated, then redirect the user to the home page, as there is no need to log in. Create a form object from login form. If the request method is post and form.validate on submit returns true, pass the form object to user_client.post_login as argument and save the response in API key. Next, if API key is available, then store it in session. Get the user in JSON format and save it in session as well. If there is any order placed by the logged in user, fetch the order in JSON format and save it in session. Afterwards, return a success message to user and redirect to homepage. If there is an error, then return a message, cannot log in. With all the logic defined above, render the HTML template login/index.html with the form object. Open login/index.html and verify if the form is secured with CSRF. Render the form field of username and password and submit the form. Logout routes will clear the session and return the user to the home page. Run the application and log in with the username and password previously created. After successful login, log out of it. In this route, we define what is going to be displayed on Product Detail View based on the selected product. We select the product based upon its slug. So first get the product using the Product API client and save the response. Prepare a form object with retrieved product ID from the last step. If the request is post, perform the following tasks. If the user is not in session, then show an error and redirect the user to the login page. Otherwise, use orderClient.post add to cart to add the product to the order. Now save the order in session and return the success flash message. At the end, render the HTML template and pass the product and form to it. In the HTML template, display the product name with image and price. Over product price, add a form with the post method, add form hidden tag, add a submit button with the label add to cart. Checkout routes with get query does the following tasks. If checks if the user is logged into the website, otherwise it redirects user to the login page. If there is no order found in session, then it redirects the user to login page with the flash message, no order found. Afterwards, we get the order from order client and display the number of items from it. If an order has 0 items in it, then we redirect the user to the home page with no order found message. Next, we check out the order from order service using orderClient.postCheckout and redirect the user to the thank you page. Thank you page first checks if the user is logged in and the order is available in session. Release the order from session using session.pop and display the thank you message. Now we'll run the application. From the product detail page, we go add to cart. The product item is added to the order with the message order has been updated. For count logic, go to macro_basket.html in templates. Now click checkout to close the order. Before building the application for Docker, modify the API URLs of user, product, and order to use a Docker network instead of localhost for communication within user, product, order, and front-end applications. In the Docker file, base image is Python 3.7. Copy the requirements.txt file. Change the working directory to Frontend app. Run the command pip install r requirements.txt. Copy all project files to Docker. Specify entry point and define CMD. Run the docker build command to create the Docker image. Now use the docker run command to run the front end in a Docker container. You can use the docker ps command to verify if the order service container is running.